All right, moving on with my slides. Let's get going, talk about this stuff, this Azure thing. My name is Grant Fritchey. I work for Redgate Software. I'm a Microsoft MVP and an AWS community builder. This is my contact information. If you want to get in touch with me after today, I'd sure like to answer any questions that are outstanding. During the presentation, feel free to ask questions. I will try to manage bouncing in and out of the avatar land thing. This is all just a little awkward right now. There's just a whole bunch of issues going on, but the presentation's working, so we should be fine. Again, if there's questions after today, please get in touch. And oh, by the way, I love Poland, and I miss the fact that I'm not there right now. One of my favorite places in the world, and I only discovered it a few years ago. So anyway, let's get going here. Our agenda is pretty simple. We want to talk about DevOps. Specifically, though, we're going to talk about DevOps in Azure. I want to talk about the tools. I want to talk about how to control databases through the tools and processes that you have. I'm going to show several different demos as we go through this stuff across multiple databases. I'm going to show you SQL Server, but I'm also going to show you Postgres, so we can see different things and the way different things work. It's just the key here is that there's more than one way to get this done. And I want to emphasize how Azure DevOps can help you solve your database deployment issues. It's not a question of that you have to follow a particular methodology. There's lots of different methodologies that you could follow. And I'm going to show you a bunch of different ways to get some stuff done. And so that's our plan. Let's all agree that we don't have to use the word DevOps. DevOps the concept is really simple. It is about an agile culture supporting collaboration. It's all about people. It's all about that focus on people and the ability of people to communicate to one another. Tools and automation and all that stuff is just supporting the process of ensuring that people can communicate better. That's the be-all, end-all of how this works, is ensuring that we can collaborate and communicate better. Now, does that mean we have to use the term DevOps? No. Does that mean we have to have someone in the company, in the organization, who is designated as a DevOps expert or whatever? No, absolutely not. It is simply a function of focusing on the culture in order to support collaboration, in order to make sure that you can do automation in support of the process that you guys have. That's it, right? So don't get too hung on the word DevOps and whether or not you're doing DevOps. And purity is not the key here. The key here is collaboration and communication. And so if we can focus on that and then just worry about the automation and tooling later. Now, what are we going to talk about today, though? We're going to talk about the automation and tooling, mainly because once you make the commitment to the culture, tooling is the hard part. It's the culture. Once you've made the commitment to make that change in how you communicate, that's great, that's good, and you'll get through that, I'm sure. But once you get in there, then you've got to have all the training and all the work and all these things to get started on doing DevOps. And so it's hard. So let's just say it up front. People before process, before tools. It is all about the human beings in the room or not in the room, right? Especially these days, most of us aren't in any room at all anywhere. But it is all about people before process and process before tools. So you do want to focus on ensuring that you've got the right people in the room, that you're talking to everyone who's engaged with whatever project it is we're talking about. And we're talking about database deployments, where we probably need a DBA to be somewhere in the area, or at least someone designated as a data expert, a data management expert, or a data development expert. We probably also need, some programmers and developers in the room. We need people who are writing the code and doing the deployments. You may or may not need additional business people. You may or may not need others, but you want to get the right people engaged first. Then you start worrying about process. Do we deploy, to a shared database in development, or do we deploy to individual databases in development? Well, we make those calls and those decisions. From our individual deployments, do we have a continuous integration environment in which we test things prior to sending them off to the QA team? That's a decision you'll make on your processes and how you want to do it. Is your CI process against an empty database, or are you running CI, a continuous integration, against a database with data inside of it? Again, process decisions that you'll be making. How do you get the decision to go to QA? How do you get the decision to go to production or staging? And then finally, how do you decide to move your code into production, and how do you make that move happen? All of these process decisions come after you get the right people in the room. And then once you've kind of laid out a process, then you can focus on tooling. And that's just how it works. That's just the general approach to this stuff that I've assisted multiple companies with it. I've implemented it myself very successfully. I've also failed a few implementations, I won't lie. But it is absolutely a doable thing. It just requires you to follow this simple steps: people, then process, and then tooling. Now, tooling, we're going to talk about, though, because it frankly is the harder part. Once you've made the decision to do these things, you've got to start worrying about it. So the two tools that we're going to talk about, two broad sets of tools we're going to talk about today, we are going to talk about DevOps tools in Azure. That is specifically what we're going for, is Azure DevOps tools. And then we're going to talk about database deployment tools. I'm going to focus on an open source tool today. I don't want to talk about anything that you have to pay money for. You're going to be paying money for Azure DevOps, so I'm not going to make you pay money for your deployment tools. There are a lot of different third-party tools out there. Microsoft also has one tool. It only supports Azure SQL Database and the others. But there are third-party tools out there that also support, Postgres, MySQL, and all the rest. I'm assuming most of you are probably working in more than one database platform. I'm sure it's 90-10. 90% of your time is in Oracle and 10% is in Postgres, or 90% is SQL Server and 10% is in MySQL. But I know that you've got another database platform, if not two or three others out there. So it's pretty common. So I'm going to focus on a tool that can go across database. So you have a simple process, then you can concentrate on the process and not worry about the tooling. We're also going to talk about Azure DevOps. With that, we're going to talk about three areas inside there: repos, pipelines, and artifacts. Repos or repositories are simply where your code goes. Where are we storing the code? And we're going to talk about pipelines. Pipelines is your flow control. That is how you decide to implement that process that we talked about earlier. And I'm going to show you several different possible process flows. We're only going to demo one easy one, but I'm going to show you three others so you guys can see a bunch of different possible methodologies, because it really is down to what's going to work well for you in your environment. The whole idea that every single environment is distinct and unique is probably not true. However, every environment is probably a little bit different than the next, and every set of processes is a little bit different than the next, and those little bits lead to a lot of big issues, right? It's the devil is in the details all the time. So it's pretty normal that you're going to have to fight with that kind of stuff. All right, let's talk about Azure DevOps. Now, Azure DevOps is a very deep and wide topic. I'm only going to skim across the surface of it, frankly. We're going to focus down on a few little bits and pieces, and I'm going to show you how they work, what they do, possible ways you can play with them, and also the beauty of the level of your ability to customize the behavior. But there's a whole bunch more that it can do that we're not going to get into. I'm not going to cover all of the management stuff that it does, because it does have a bug tracking, work assignment, team management aspects to it that we're not going to get into, all of which are useful, many of which are great, some of which are meh, but we're not going to cover those today. But I want you to know that they are there. So if you do choose to use Azure DevOps as the tool that you're going to pursue as a way to move your way through these kinds of deployments, you've got a methodology for doing it. That's the whole key here. Now, the one thing I really want to emphasize is that Azure DevOps is your first step for security. You can control who gets into, can see, can access, can programmatically modify, or simply can only look at reports of your Azure DevOps platform. And I would very much recommend that you clamp down on security. I mean, we probably are all very aware of what happened with just this kind of software and the company SolarWinds last year. They did hit an issue, and they weren't alone. There were several other companies, but SolarWinds was kind of the big one in our community. There were some issues from an automated database deployment or application deployment software, and it was mismanaged, it was insecure, and it led to very serious problems. So please, day one, security should be one of the first things that you're thinking about when you're starting to set up Azure DevOps. Do not hesitate for that. Now, the interesting thing about Azure DevOps is they have these things called agents. And again, we'll get in and I'll show you one. I'll show you two. But the idea of the agents is it allows you to control what can be done. So this is all about security again, because you can set up an agent so that it is cloud only, or you can set up an agent so that it runs inside of your network, inside of your local machines. So you can use Azure DevOps tooling to deploy to the cloud, of course, out to Azure, Azure, right? Azure to Azure is always easier, but you can also use Azure DevOps to deploy locally. And I'll give you a show on how to do that. But that does mean that agent that runs locally, you sure don't want to give them too much access. You want to ensure that they can only do the things that they do, which it suggests you probably are going to want to set up multiple agents. One for dev, one for QA, one for pre-prod. If you have an agent for production, again, that's your call, and I would recommend it, but make it so that it only accesses the production servers and only has specific access on those servers. If you need two production agents, one to deploy the application and one to deploy the database, cool, do that. Manage your systems so that they are secure. You got to remember, when we start automating the ability to make changes to servers, you're exposing something. So security should be something that you think about step one, day one, all the way through the process. Are there any questions here? I'm going to bounce just over to the avatar land. Anybody got a question or anything that we've talked about so far? Not even sure how to see if there are questions, tell you the truth. Okay, cool. We'll keep going. There we go. All right. So first up is repos, the repositories. This is where your code gets stored. Now, Azure, they first built the Azure DevOps tools several years back now. It's been quite a while. It was the original Team Foundation services moved to the cloud is really what it was. And so when they set it up initially, the repo that you had one. Team Foundation services. That was the one repo that you had, but they now have opened it up. So you can go into Azure and you can use Git, GitHub, or TFS all automatically. If you want to use another repository, you can, but it's going to be on you to set it up and configure access to it for the Azure DevOps. Azure DevOps has built-in tooling to support Git, GitHub, and TFS. Want something else, just set it up. But here's the key. Your database is code. And anyone who doesn't believe me, we can have that fight. Your database is code. It really, really is.
Right.
Yes, the data is not code, but everything about the database itself is. All right. Next up is pipelines. The pipelines is where we take the processes and turn it into action. And I'm glad they call them pipelines because it really makes sense to me. I've always called this a flow control tool. So back when we were working with Team City or Octopus, started working with open source Jenkins, AWS DevOps, all the stuff besides Azure DevOps, it's all about flow control. Azure DevOps is the same way. They've got the pipeline set up, and the pipelines is where we start to control the flow, where we decide, if this, then that is a whole series of steps for defining how we do our deployments. The pipelines do work both in the cloud and on premises through the agents. This is also where you're going to be worrying more about security, because you are going to pick and choose which agent can run what and define who can control those things through your pipelines. So you're going to want to be very cautious about how you set these up. It's not magic. It's just being thoughtful. It's not hard even. It's just thinking about it before you do it, ensuring that you're allowing for the fact that you may have to change the way things are set up. But the whole idea here for the pipelines is really simple. It's a YAML definition file, although there is a GUI, and I'll show you the GUI. But it is a YAML definition file. And by the way, Azure, or I'm not saying Azure, oh my gosh, my brain. I need a new brain. Tool, Visual Studio Code, VS Code, is your best tool to help you manage YAML, because it has a YAML interpreter, which makes it a whole lot easier to read YAML and type YAML. So if you don't have VS Code, I recommend going and getting it. It's very handy once you start to get into automating all these things. But anyway, the beauty here is that pipelines really are just going to run commands that you tell them to run. And the YAML is going to run the stuff that you want. So for example, I generally run everything through PowerShell. And so I've got PowerShell, I can run my commands, and off it goes. Now, if you're running against Linux systems and you want to run Bash or Korn or something else, you can do that too. You just configure the YAML slightly differently than I do. But because you can run everything from a command line driven process, that means you can automate anything through these pipelines. So there's no limitations here. I'm going to show you a few examples when we get to the demos, but it's not in any way a limiting factor, because you can do anything you want to through there. Of course, that's also why I've said 5 or 6 times now, and I'll probably say another 5 or 6, you do want to think about security, because you can do anything you want to here. And if you set it up inappropriately, you may make it so anyone else can do anything they want to. And we don't necessarily want to open up the world like that. So you do want to have some exercise some caution on that security. All right, next up is artifacts. Now, artifacts are really simple. You can make it so that when you're doing these steps, it spits out SQL. So if you're doing a MySQL deployment or an Oracle deployment or a SQL Server deployment, you want to spit out the SQL that was done, do it. I recommend it. In fact, I've gotten over it now, because I will do deployments all the way into production. But what I used to do was deployments all the way up to my staging server. And my staging server was always a copy of production, an exact copy. And so what I did then was create the deployment to staging. Hey, it was successful. Cool. Capture the SQL that I used into a file, an artifact, and then use that to deploy to production. And that way I didn't try to generate a new SQL statement for production. I had a tested SQL statement for production. Now I'll generally go all the way into production, just because I get to the point where after setting up the process, after testing the process, after validating that it works, and then running it 5, 10, 20, 100 times, I'm confident in my process. And so I will now move it all the way into production. In the old days, I was much more paranoid, much more of a control freak. And so I didn't trust the process entirely. I wanted that last check. But you can do that. You can set up these processes any way you want to. Now, the beauty of generating the artifact and the beauty of generating that T-SQL and storing it, again, back into your source control, is you get the mechanism of auditing. Whoops, something just went weird. That was weird. Screen just jumped around. Sorry about that. And then the next thing you get is historical tracking. So you can see what changes have been made over time. Yes, source control gives you that too. But as we all know, databases have different scripts for making changes versus the definitional script that you're going to see in source control most of the time. Source control is going to see create table. It's not necessarily going to see alter table, depending on the tool you're using. The tools I'm going to use today, though, they actually have store stuff as alter table and all that. So it's a completely different tooling set. All right. Finally, you definitely need a database tool. You can build your own. I've done it. We built a tool that was basically a manifest. Here are the scripts we want to run them in this order. It wasn't that hard to put a tool like that together. It was a little bit of work, and then it was a lot of work to maintain over time. So I would, again, I do work for a third-party organization, and I would love for you guys to buy our tools, but I do recommend that you probably should look at least a third-party tool, because this stuff gets complex really quick, and trying to maintain your own is hard. Like I said, if you're only working with SQL Server, only ever working with SQL Server, Microsoft has a free tool, the SQL Server Development Tools, SSDT, but if you need Postgres or anything else, you're going to have to look elsewhere. So I would look out there and track one of those down. Now, the tools that we're talking about, I'm going to show you Flyway today, but we've also got the Redgate tools. Idera has some tools. There is Liquibase. Let's see, there's another one I'm not thinking of. Yeah, I can't remember. There's one other. Explore these tools. They all work in different ways. Now, the one thing that you're going to notice is that you can divide them up into roughly 2 camps. And camp number 1 is what we would call state. State is comparing 2 things: a backup and a database, 2 databases, or hopefully, and this is what I recommend, your source control system and a database. Compare the 2, you identify the differences, you generate the SQL necessary to change from one state to the other, and then that's how it works. So state-based tools work on the idea of that comparison. The other kind of tool is what we'll call migrations. And the migrations is effectively a manifest of changes. It's not completely. I'm going to show you when we get to the Flyway. Flyway does things a little differently. It has the ability to rerun scripts. It also has the ability to put in undo scripts, which is not something that's normally built into other tools. So there's a whole bunch of functionality there that's a little different, but the concept is pretty simple. It's a manifest of changes to get from version 1 to version 2. Here are the scripts that must be run and the order in which to run them. There's a little bit more work up front to use a migrations tool, because you do need to kind of like generate those migrations somehow. But once they're working, the migrations tool actually is a little more stable, a little less brittle than the comparison tools. The comparison tools run into issues when there's the potential for data loss. And so you avoid the data loss issue by generating your own scripts. Well, if you're generating your own scripts, couldn't you just use a migrations tool to make sure they get deployed right? And the answer, of course, is yes. So I lean towards migration tools, but state-based tools do work. But that's where the database tooling comes in. All right. So finally, deployment targets. Sure. Synapse, Azure SQL Database, SQL Server, Azure DB for MariaDB, Azure DB for PostgreSDB, for PostgreSQL, Oracle VMs, Cosmos DB. All of these can be done directly from Azure, directly from the Azure DevOps pipelines that we're talking about. So we're really not limited. And any of these can be local as well. So if we want to run to Oracle, we can do that. There's literally not a limit here of any kind. If you can make the connection, there's probably a way to automate the process. So don't feel like, well, we're working with MariaDB, therefore we can't do this. Well, no, you can. We're working with Postgres, so we can't do this. No, you can. It's just some of the tools, for example, like I said, SSDT, are SQL Server only. So if you need to go to Maria or Postgres or MySQL or Oracle, you are going to have to look at other tools. But that's just again, that finding your process, ensuring what you need, and then figuring out the tooling later. Okay, that's that. Let's go and play with toys. Well, actually, we'll pause a second. Any questions on anything that I've gone over? I'm just looking to see if I can tell who's raised a hand or whatever. No? Okay, great. All right, someone tell me that you can see a whole list of Azure DevOps projects. Many of them with the same name, because I'm not an imaginative person. Can you guys see my web browser?
Yeah, we can see it.
Yay, cool. Awesome. All right, well, these are a whole bunch of different test projects I have. These are public projects too, by the way. If anybody wants to track down Scary DBA, you guys can look at these things. They're not hidden. I don't hide them away at all. These are my test projects. They're development and testing and toys that I play with on a regular basis. But you guys can get in there and mess with them too if you want to. I'm going to show you first one. Actually, no. I'm going to show you. Yeah, let's show you the active one first. Let's show the Postgres one first, and then we'll get into the other ones. Now, the Postgres project is pretty simple. I haven't done a whole lot with it right now. I've kept it very simple. But let's start with the repo. If we go to the repository, we just see files. This is just a simple file folder structure. It's showing the files laid out for what we need. I've got a couple of test scripts in the front. All right, so if we take a look here at the folder SQL, then we can see a whole series of SQL scripts. Let's pause here for a second, because this is mostly a demo of Azure DevOps, but I don't mind explaining how the open source tool Flyway works. The idea here is very simple. Flyway works off a naming scheme. So if we look down here at v1.1, you have to name your files the order in which you want them to run. So v1, v2, v2.1, v3, v3.1, v4, v4.1. No, you don't have to name them 4.0 and 4.1. I just never created a 4.2. Probably should have, just for the demo purpose. Let's switch to pipelines and start talking about pipelines. How much time have I got? 20 minutes. All right. Plenty of time. We're okay. So this is the pipeline I'm working on right now. It's a very simple pipeline. Let's go ahead and take a look at it. Click on Edit. Excellent. So what I've got here, and this is the GUI. Normally, you're going to want to work a lot of this. You're going to spend time working in YAML. The GUI is here, and I like to use the GUI because it makes it easy to kind of lay things out in a way that's visually a lot more satisfying than YAML. But the idea here is what I've got is just three simple PowerShell commands. First one is I am resetting my database. So what I'm doing is I'm running a Docker run, and it's creating a Docker container. I've got a particular password. For some reason, when you start the Docker container, it's some kind of an asynchronous command. And so I've got a 6-second wait to ensure that it's online. And then what I'm doing is making the connection to it. And then once I've got that connection, I log into it and I create a database called Ham Shack Radio. So this is a continuous integration process. But this particular continuous integration process is testing without data. So it's doing creating a brand spanking new container with a brand spanking new Postgres database on it. And then it's creating a deployment against that empty database. Now, this is a really simple validation, right? This is the kind of validation that's meant to be run anytime anyone makes any kind of code change. Now, is it going to do a full-blown set of tests for my data and my deployment mechanisms? No, it's not. You're going to want to set up another process to do that kind of testing. But I've made the choice here for one kind of process. Is this kind of process better than another kind of process? No, it's different. That's all that's going on. Man, my screen's jumping around in a weird way. Hope you guys can see stuff. But it's all about creating your own process for what you need. In this case, I've decided that this process, I want a blank database and all I want to do is test it. So I've got this container and I create the database. Then I'm sending another PowerShell command. In this case, I'm running Flyway. Flyway is connecting up to the database that I've defined, to the server I defined on that container. And then it's doing what is called a dry run. And the dry run is running a migration command, but it's outputting it to a SQL file. So I can actually go and look at the SQL that was run. Now we can take a look at the YAML definition here, and you'll notice that it's not real different. It just says steps, PowerShell, and then you get to define whatever ones are running. And you'll notice that the PowerShell in it is exactly the same as what we see here in the GUI. And then finally, I'm stopping the Docker and removing it. So I've got a Docker container that I create. I put a database on it. I do a deployment to that database, and then I throw it all away. And so this is a continuous integration process. And let's take a look at how it works. So what I've got here is I've got the script that I'm going to save. Come on. It is acting funny. There we go. File save as. That was hard. Wait, no, that's not right. Come on, file. Wow. This is a fun day. All right, save as. Let's see if it works this time. God, you think I was trying to do something complicated. All right, so let's go down here to 5, and just to prove that we can, click on this, and we're going to change the description to 5. Would you please do what I'm telling you to do? 5.2, and we're adding the SQLDay table. And yeah, it says 5.2 because we're not. And yeah, we skipped 5.1, but that's okay. All right, so we've saved that file. Well, you'll notice over here on the left side of my screen, my source control has said, hey, you've made a change. You've added a new file. Okay, cool. Let's stage that change. Now, this is all going to be occurring locally. So I've got my own local Git repository. In that Git repository, I can update stuff, pull stuff, push stuff, do whatever I need to do to maintain it over time. And then once I'm ready, I can say, demo for SQLDay, and I can commit that stuff locally. So I don't have to commit it until I'm ready, until I've tested it, until I'm sure. That's still just a local commit. So it mean I can track all my changes locally and keep track of my code and my databases locally. But finally, once I'm ready, I'm going to go ahead and hit push. And so it's going to push this from my local laptop where we're at now up to Azure DevOps into the cloud. So if we go back here and get back to the pipelines, should see, notice that little blue thing right there. Let me just zoom in a little bit. Come on. Boy, golly, everything's acting funny. It's amazing the demos work considering how funky everything is behaving. Come on, zoom in. There it goes. All right. See how that thing's turning? That means it's actually doing stuff, but we can watch it. So it'll let me click on it. Good Lord. All right, click on it. And we can see the output. Come on. Do what I'm telling you to do. Uh-oh. Says it failed. What? No, there it goes. It's just going. Okay, cool. Oh, no, it did. It failed. Huh. All right. Figures. Oh, I didn't start Docker this morning. Oh, no. All right. Well, that's on me. All right. Well, you get the idea. I didn't start Docker, but this would have run. Then it runs the Flyway command, and then it would remove everything and go the other way. Oh my gosh, I feel silly. But you get the idea. This thing is actually functionally running, and it would have worked if I had set things up correctly. But because I didn't set it up correctly, it failed. Let's go ahead and take a look at some of the other pipelines that I had defined too. This is a different project, and it is using different tooling. But the idea here is the same. So what I've got is I've got a continuous integration process. I've got a pre-production process, and I've got a QA process. And what's going on is each one is triggered in different ways. So they do different deployments. Go ahead and edit one. Whew, good Lord. All right, there it goes. Time, 10 more minutes. All right, no problems. Okay, so this one's doing a code coverage test first. So the first thing it's doing is it's running T-SQLT, which is an open source testing tool. I'm running T-SQLT, an open source testing tool, and I'm running SQL cop tests. Again, a second open source tool set. So I'm running these open source tools to validate my code. Then I'm running the build. So what I'm doing is for my continuous integration process, if my build does not work, I'm not going to do if my tests are not passed, I'm not going to run the build. I'm not going to run the deployment to my database. Now, in this case, the deployment I am deploying to an actual database. I'm not doing a reset like we did before. This is a database with data in it because I want to validate that my deployments are working so we can see what's going on. And so this is another kind of continuous integration process. I've added an additional step, testing for that code coverage, and then doing the build. So this is just another way to go about this. There's more than one way to get these things done. And I like to show these off so you guys can understand that it's not just a question of, here's the one path. There's lots of paths. Go and edit this QA one because it's triggered in a different way. Oh, and by the way, both the initial pipeline that we ran that failed and the one I just showed you are triggered by, we got back into the CI by accident. Man, the brain is acting crazy. Both those are triggered by updates to my source code. That thing jump around. So odd. This one is very different. Hit edit. Where I did. Oh, it's back on CI again. Why does it keep doing this? I swear, guys, this isn't me. Wow. Okay. Come on. Hey! Woohoo! All right, so this one is different because what it's doing now is the deployment is triggered by time. I've got it set up so that it only runs based on dates and times. So it runs once a day. It's a scheduled. Oh, it's disabled right now. Yeah, I turned it off because it was causing problems. But the idea here is that it just does a simple deployment. All it's doing is just the straight up deployment that I had for the other one. It's not running any kind of additional validation on the code. It's deploying to a different database, but it's run on a schedule. It's run once a day. I was running it once a day at noon. But it's just the idea is that you can schedule them as well as control them that way. All right, let's see if we can get in and look at the last one. Oh boy. Whew. Okay, cool. All right, so this one I am using a Redgate tool for this one. What I'm doing is I'm deleting a clone image. So I'm deleting this image of the database, creating a new one from a backup. From that, I'm creating a clone, which is a copy of the database. So I'm creating a clean database, and then I'm running my build. So I'm adding in just multiple steps to the process. It's still the same process at the core. It's the same idea that we showed you in Flyway deployment. This is no different. It's just a question of what we're doing in addition. So what you've seen here are 4 different possible processes, all run through Azure DevOps, all leaning on Azure DevOps to do most of the work, but you do have to plug in that one little bit of tooling. Let's see, we can go ahead and switch back to the slides. All right. Woo, that was painful. Okay, so what we did was we went from Azure Data Studio where we made some changes. That went into local Git. Git went into the repository out on DevOps. The changes to the repository fired off the pipeline. The pipeline used Flyway. Flyway generated a SQL artifact and did a deployment to a database. And that is the entire process in a nutshell. So that was everything that I wanted to show you guys was right across there. So you can see that. Thank you very much for putting up with my frustrations through this process. And are there any questions that I could answer at this point?
Your worst conference performance ever? Or have you ever had worse than this?
Oh, trust me, this was not my worst one. I've had much worse than this. Except that my entire machine is acting like it's being possessed by demons right now. Wow. I'm not kidding. I can't. Okay, there it goes. Woo. Wow, that was painful. All right. Are there any questions in the 3 minutes that we have left? Oh, yeah, there are stuff coming in there. Okay, hang on. I see where I need to be. Let me figure out how to get there. Oh, come on. Woohoo. I'm very curious about your general comments on Flyway. Flyway's a great tool. Open source, so it's, free, quote unquote. Anybody who believes that's crazy, by the way. There's no such thing as free. But anyway, great tool. I like the simplicity of it. The issue that you may run into with Flyway is because it is so simple, which the simplicity means you can do anything you want. But that simplicity also means that you are responsible for doing quite a bit of the work. You need to generate those scripts. That's not the end of the world. And in fact, I kind of prefer to generate the scripts myself. Can you use other tools to generate them? Absolutely, you can. Um, Anything you want to in terms of generating those scripts, but you do have to generate the scripts, supply them to Flyway, and then Flyway can very intelligently run them and run them for you. And if you remember, I don't think they're sharing my screen anymore at this point. But if you remember on the Flyway, there was the R underscore file names. Those are repeatable runs. So, say for a store procedure or a view, you could run them every time you do a deployment. So, any kind of updates that have occurred to those, they can be updated constantly. There's also ways to pick and choose. There's a whole bunch of stuff. And then Flyway also has a Teams version, which is the paid version, and it does a bunch more stuff. The core Flyway is fantastic. I mean, just fantastic. I strongly recommend it, but be ready for the fact that you're going to have to do work yourself. Hopefully that answers that question. All right. SQL Server uses CPU. Maybe this is a GPU problem. Yeah, no, I'm not running SQL Server locally though. So whatever the heck is going on my machine, it's all local. So, especially when compared to Visual Studio data tools. Okay, cool. Okay, let me just add that in. Then the data tools. The beauty of data tools is that it very much does a lot of work for you, which is cool. So script generation is something you're not going to have to sweat. But the issue that it has is it does not have any kind of migrations capability. It does if a script is going to do a data breaking change, you have a choice. Don't deploy at all or deploy and lose data. Well, now we all know you can't deploy and lose data. So what do you have to do? With SSDT, what you're going to get into, and I've done this myself because I built automation processes with SSDT, is you're going to have to get into pre and post deployment scripts, meaning you will run a script prior to deployment to make some of the changes that you couldn't make through the tool. Then you'll run the tool. Then you'll run some additional cleanup or additional secondary steps to ensure that you complete the deployment successfully. Is that a pain in the bottom? Yes. Yes, it is. But it does work. It's just something you'll have to plan for. And that's the whole idea is that those breaking changes cannot be deployed from SSDT. So you need to have a way to deal with that. All right, let me see if there's any other questions that come in. Don't see any. My screen is fighting me the whole way. Good Lord. All right. With that, I think we are out of time. So I appreciate you all sitting through this. I really, really sincerely hope that SQLDay invites me back next year and I can get over to Poland and see you all in person because one, I love the event, and two, I love Poland. So can't wait to get over there again at some point. Other than that, thank you very much. Don't hesitate to reach out to me if you have questions after today. I appreciate your time and have a great day. Thank you. Oh, and look at that. The avatars clap. How cool. Thank you. All right, let me get off the stage.